So next is type of data structures, like how many type of data structures is used. So in this, first is array, a collection of items sorted, stored in a contiguous block of memory, used when the number of elements is fixed and you need to fast access by element. Now what it means, like we have 20 to 20 numbers and we need to store. So this is arrays look like this, and this is in heap memory. This is stored in contiguous, like if this block address is 101, then second must be 102, third will be 103. It's not like this have 101 and this have 1010. No, it's not possible. In array we have contiguous, like if we need to 100, if we need to 100 byte of storage, then our system will assign this 100 bytes in contiguous memory location. Like if we have one address, if we have base address of this index, then we can get all the array, like base address, through this base address we can get this index and all the index, whole array we can access it. So this is our array. And in this, as we know, like in array we have stored only same type of data. Like if we stored in this block integer, then in whole array we can store only integer, because we create a array of int type. So in this array we only store the element of int type. And also in this we can access directly index, like if we want to access this the element of that location. So arrays indexes start with 0, so 0 1 2 3 4 5. We can directly access it by through arr 5, and this will return the value of this index. We directly access it. So this is our array introduction. We know more about this in further videos. So next is list. Now list is a collection that can store element in any order and allow dynamic resizing. One more point of array is like it is a fixed array. When we declare it, we need to declare with it with size. Like if we need 5 block of array, so we need to declare 5 size of array. It is necessary to giving size here. So but in list we have a dynamic array. The In this we have dynamic array, and we can store the any order that allow any order, and allowing dynamic resizing, more flexible than it. In this, the array and list is difference is only that it is dynamic array. We can we declare and list, and whenever we put new element, it will reassign, it will resize it. If we store only one, then only one byte of memory will, only 4 byte of memory, because we store integer type and integer have 4 byte size, so only 4 byte will be used. After that, when we start insert second element, then 4 byte will be added, and now 8 byte will be used. Not like array, if we have allocate size of 20 byte and we stored only 4 byte, then this 16 byte will be free and wastage of memory. So in this list case, doesn't have wastage of memory. Now third one is stack, collection of element where you can only add or remove elements from the top. And uh, now this is stack, and stack is working on LIFO principle. What is LIFO? Last in first out. What it mean? Like stack is look like this, and in this whatever the last element we push, that only accessible. We cannot pop any other element. So if we put initially 4, then 2, then 3, then 1, then 9, so when we need to use 3, this 3 we initially push this and stored in another data structure, then pop this, then we use pop this 3 and we cannot directly pop 3, like in array we directly access arr fifth element, but in stack we can't use. So this is the principle, last in first out. Whatever element the lastly inserted, it should be first we can access it. This is stack. And next data structure is linked list. Linked list, a collection of nodes where each node point to next one. great for dynamic memory allocation and efficient insertion and deletion. In an array like here array, if we want to insert the element in that particular area, so we need to do multiple operations, like firstly we move here, and then after that element from here to here, we need to shift one next location, then we insert in that location. But in case of linked list, we cannot do, we doesn't need to do any lengthy operations. The time complexity for insertion and deletion is O of 1, big O of 1, which is in case of array is O big O of n. In time complexity of linked list is O of 1, big O of 1. In case of array, it is big O of n. So linked list is look like this. This is our first node, which is pointing by head pointer, and in this we have data, and in this we have stored address of next node. This is our linked list look like this. So here is 1, 2, 3, 4, and last node have null pointer. So in this, if we want to insert element here, so what we need, we traverse this, and we simply break this link, and this will, if we have this new node, then this will and here data is this will point this node, and this node next pointer will point this node. Only we do this operation, and this will be a big O of 1 time complexity. Not like array, we need to all the elements shift to next one location, then we insert in that location. In this we have only big O of 1 time complexity. This was the biggest feature of linked list. Here is dynamic memory allocated, so no wastage of memory like array. Here we need to insert as much as node, we insert simply, and whenever we delete node, we simply break the link, and here we stored null. And if we delete the middle of the node, then we simply, if we want to remove these two, then this next pointer will directly point this 3 node, and we have deleted second node. Next is queue. Queue is also like a stack. Stack is working on LIFO. It will work in FIFO concept. So if we know the queue is look like this, and here two pointers are working, front, and second one is rear. And what is the work of rear and front? Front is front pointer is used for inserting element, and rear pointer is used for deleting an element, like accessing. FIFO matlab means whatever element we push first, this will be accessed first. Not like we have put first, we have put elements in, like initially we put 1, then 2, then 3, then 4, then 5. So if we push this one first, then we rear pointer is getting here, and we can access it through rear pointer, and we insert the element through first front pointer. So this is the introduction about queue, and we'll discuss in detail in further video. So let's move in. Next is hash map. So hash map is basically store the data into key value pairs and allowing the fast lookup. Like it is the most common data structures that used in optimization, all the problem optimizing using hash map. This data structure is because we store the value in key value pair. This is most important data structure, so we will discuss more about this in next video, in further videos. And next data structure is tree. Tree is also store the element in a linked list form, but it is in hierarchical structure. Like if we see a general tree, it's like this is node, then this one, this one, this one, here two child, and this one two child. If we need to in this node we have these two child's address, and this further have two childs, and both of these address will be stored in this node. So if we want to access this node, then initially we go to root node, then in root we'll go here, then we'll go here. So this is there are three different type of visiting this tree. It's called in order, pre-order, and post order. In if we talk about order traversal, firstly we visit node, then left child, then right child. And in pre-order, we initially visit right child, left child, then root node, then right child. And in post order, we visit child, then right child, then root node. This is the three way of visiting tree. It is also very important data structure, and it is used in hard level of problems and hard level of coding. So it will also be discussed in later videos. Next is graph. Graph is a extended version of tree. Like if we in a tree there is no cycle occur. Like these elements will stored like this. These have two child, and further these have two child, and these have. It's not fixed like only have two child. Will be can be one child, can be more than two child. So and there is different type of trees. The child property will every tree have their property. Like in binary tree we have only two child. And in graph, if we there is a cycle occur in tree, so that's called graph. Like 0 1, this is called graph. All nodes here, nodes is this is called nodes, and this which connect to nodes is called as which called as. So the collection of nodes that represent the relationship often use network and paths. Network and paths means this line which connects two nodes. These nodes is also called vertex in graphs. Is called vertices in graphs, and as nodes in tree. So these all are type of data structures. Next is data structures are key part of coding interviews. Like every problem should need to store data. So for storing data, for solving that problem, we need to use data structure. So this is the key part. Right data structure for the task can make you code more efficient in term of speed and memory. Like if we then there is a problem can be solved in array and using hash map both. So if we use right data structure, like we use hash map, so optim will be increase the speed, and will use less memory, and will use optimize our course. What is what Which is what interviewer are looking for when they ask to solve problem. Like interviewer is basically know that how can you optimize, how much you can optimize coding problem, and how much use less memory.